Okay, for those of us at home, welcome. I was just telling the class that we are going to finish the retakes for the Unit 4 test on Friday. Friday is our retakes day. So we will finish the practice work and retakes on Friday. Today we are going to finish going over CO31. We started it last week. I was having technical difficulties and we ran out of time. So we're going to go over that CO31 again. This is our last objective before our test. So we have going over CO31 today. Tomorrow will be a review day for all of Unit 5. Wednesday will be practice test. Thursday will be the test for Unit 5. Then Friday, we're going to finish our practice work and retakes for the Unit 4 test. So next week, we can focus on any practice work or retakes we need to do for Unit 5. So that's our week in math. We're finishing today, reviewing tomorrow, practice test Wednesday, real test for Unit 5 on Thursday, and finishing our practice work and retakes on Friday for the Unit 4. So for those of you who didn't get to do the practice work and retakes on Friday, you'll get those this Friday. So you'll get caught up on any retakes you need to do for that. So CO31, I can graph a function using a function table. So last week, Thursday, we spent a lot of time reviewing that function table, how we take the x and we put it into our function for the x. We substitute that number in, and that's our input. We substitute it in, and we get out of it the output, the answer, which is the y. The function tables we looked at last week looked like this, where we had our input. Oh my, this is not wanting to write really easily for me. So we have our input. It's the same as our x, and it's also called our domain. So all three of those mean the same thing. Last week we were using that -2, -1, 0, 1, 2 for that input for the domain. And what we get out of it, once we put that x into that function and we do the math, we get the output, which is the y and the range. Now we looked at our function tables going this direction. The function tables that go up and down are the same thing. It's just our x is going to be on the left side, our y is going to be on the right side. So it means the same thing, even though it's turned on its side. We still have the x and the y, the input and the output. So our x is our input, our y is our output. We just turned it, but it means the same thing. So if we're going to graph our function, y equals 2x plus 1. We want to take our x, whatever we're going to put in for x, we're going to put in for the x in our function. We're going to do the math, and it's going to give us our y. So we're going to use this function table to write a list of ordered pairs. So if we're going to use that same x domain that we used last week, we're going to fill in -2, -1, 0, 1, and 2. Then we're going to take that x and we're going to put it in for the x that's in our function. So our first one is -2. So I rewrite it and I say 2 times -2 plus 1. And I need to do the math to find out what the y is going to be. What is our output? Remember with PERMDAS, the first thing we do is multiply. What is 2 times -2? Gregory? 2 times 2? Yeah, it would be -4. plus 1. What is negative 4 plus 1, Gregory? Negative 3. So we put that in here for our y. So if x is negative 2, y is negative 3. Now we're going to substitute in our negative 1. 2 times negative 1 is negative 2 plus 1. Negative 2 plus 1 equals negative 1. So we put that in for our y here. So negative 1x is a negative 1y. Now we're going to substitute in our 0. 2 times 0 plus 1. 2 times 0 we know is 0 plus 1. 0 plus 1 is 1. So we put that in for our y. Now we're substituting in our 1. 2 times 1 is 2 plus 1. 2 plus 1 is 3. So we put that in for our y. Our last x we have to substitute in is a 2. 2 times 2 plus 1. 2 times 2 is 4 plus 1. 4 plus 1 is 5. So we put that in over on this side. So remember how we take our x, we put it in for the x in our function, you do the math, and that's how you get your y. So now that we have our x's and our y's, we can make our ordered pairs. So we have negative 2 goes with negative 3. We have negative 1 goes with negative 1. We have 0, 1. We have 1 and 3. And then we have 2 and 5. So we have all those ordered pairs. The next step is to plot them. So we wrote out our list of ordered pairs. Now we need to plot the ordered pairs on a coordinate plane. When I say coordinate plane, what does that mean? What is a coordinate plane, Tristan?
It's pretty much just like a coordinate graph.
It's the graph. You need to graph it on the graph. So if we look at our graph, which of these axes is the x? Will? The one going up and down or going across? Going across, that's horizontal. So that is our x, is the horizontal going across. So that means our y has to be vertical, going up and down. Remember, our 0 is the origin right in the middle. So then it is positive numbers going from the middle to the right and going up. It is negative numbers going to the left and going down. So now we need to plot our points. So if we're at negative 2, negative 3, the first one is always our x and then the y. So negative 2 we find on our x-axis, and then we go to negative 3. Negative 1, negative 1, 0, 1, 1, 3, and 2, 5. And then we connect our dots. I'm doing it with a marker here on the smartboard. Mine's not very lined up very well, but on graph paper it would be a straight line connecting those dots. So notice that all the points lie on the line. Any other ordered pairs satisfying that function y equals 2x plus 1 would also lie on the line when graphed. So if I were to put a 5 in for the x, what I get for my y, if I make that into an ordered pair, it would be on this line, just farther up on the line. If I put a -5, what our answer would be on that line. Okay, so you take your x, you put it in, you get your y, and all of them for the same function, they're going to have that same slope. They're going to be on that line. Is that making sense? Okay, we covered that on Thursday. I wanted to review it, make sure that we're really understanding it. Let's look at the rest of our page here. Writing and graphing a function. Make an output table for the function y equals 2.5x (2.50x), which is 2.5x. Then plot the ordered pairs. So we're going to use, I'm going to tell us what our input is going to be. So we have our x and our y. We are going to use for our input 0, 1, 2, 3, and 4. Our function is y equals 2.50x. So we need to find what our output is going to be. What do I do first? If I know my x is 0, how do I find the y that goes with it? Tristan? If I know my x is 0, what do I do with the x to find the y? What do I have to do? I have to put it into my function. So I would say y equals 2.50 times the x of 0. What is 2.50 times 0? Brielle? It's going to be 0. So I'll put a 0 in for that y. So now I need to substitute it in my next one. Y equals 2.50 times 1, because I have a 1 here in the x. So what would that y be, Tristan?
2.50.
Yeah, 2.50 times 1 is 2.50. What do I do next, Gabby? What should I substitute in for my x? The 2. I have a 2 here. I need to find the y, so I'm going to substitute in a 2. What is 2.50 times 2? Will? 5. So I'm going to write that 5 in right there. What do I do next? Nolan?
Wait. I'm not sure.
So I found my 0, 1, and 2. I found what the output is for those. What's the next one I need to find the output for?
3.
The 3. So I need to put the 3 in for the x. So I need to do 2.50 times 3.
Oh.
What is that, Anthony?
7.5.
7.5. So I'm going to put that in to my table. What is my next step, Lily?
You're gonna put the 4 in.
Yeah, I need to put the 4 in for my x. What is 2.50 times 4? Peyton?
10.00.
10. Yep. We don't have to put the 0.00 because it's zeros. So 2.5 times 4 gives me 10. So now I have my function table. It says then plot the ordered pairs. And it should say graph them. So I forgot the word graph there. So I need to write down my ordered pairs. What is my first ordered pair? If I'm looking at my x's and my y's, what's the first ordered pair, Zoe?
0,
0,
0.
0. What is my next ordered pair, Josie?
1, 2.5.
1, 2.5. What is my next one, Ryan?
Your next one would be 3s and then 7.5. Oh, 2, 5.
2
I was like,
and 5. What is my next one, Kira?
12.
So let's put away what you're
I
doing.
already did it.
So you should be following along. So look up at the board. What's our next ordered pair?
It's 4 and 10.
No,
Which one are we on?
right here.
Okay, 3 and 7.5.
3 and 7.5. What's the next ordered pair, Adrian?
4 and 10.
4 and 10. So now we have our 5 ordered pairs. What should I do next, Kira?
You should graph
I need to graph them. So remember that 0 is the origin in the middle. 1, 2, 3, 4, 5. I don't need to go any more than that. I do need to go all the way up to 10 for my y's. I don't need any of my negatives. So my first ordered pair is 0, 0. So that is right at the origin. Then I have 1 and 2.5. So it's going to be in the middle between 2 and 3. Then I have 2, 5. 3 and 7.5. And then 4 and 10. And you can see that they are all in a line. So if we were to keep adding numbers on and we continued that line out, we would be plotting numbers that continued on that same line. On the bottom, it says identifying linear functions. Not all graphs are lines. The ones we've been working on have been straight lines. Nor do all graphs represent functions. Tell whether each graph represents a function of x. If it does, tell whether the function is linear. So this gets a little bit more complicated here. If we look at that first one with that straight line, does it represent a function? It's a straight line. Is that what we've been working with?
Yes.
Yeah, we've been working with those straight lines. It is a linear function because it creates that straight line. So yes, the straight line is a linear function. So this graph represents the function of x. The function is linear because the graph is a line. We look at B, it's if we look at the way it's going, it's curving. Oh my, I'm not really matching up very well here. It's curving to the left there. This graph does not represent a function of y. For each value of x in the domain, excluding -2, there's more than one value for y. So if I were to put in a 3, I could get an answer that goes up into the positives or an answer that goes into the negatives. Because there's more than one y, it's not a function. Does that make sense?
Yeah.
When we do our function table, you put in x, you get one y. That's how we know it's a function. You're only getting one y. If your graph has more than one y for the same number, it's not a function. Let's look at our next one. If I put in one number, am I getting one y? Look at that line. It's a curve, but look at how it's curving. If I put in an x, do I get more than one y? Or is there only one spot for that y? Tristan?
They're both the same.
Well, if I put in -1, I would get +1. So it's a function because you're only getting one y for each x. So it is a function because if you put in one y, you get one, if you put in one x, you get one y. But is it a linear function? It's not a straight line. So this is a function, but it's non-linear. We are going to stop with that. And I'm going to say goodbye to my friends at home.